We've been glossing over some details of the set operators in SQL that I'd like to clarify. Let's begin with the semantics of sets. Sets are mathematical objects you may be familiar with from a previous math class. A set is a collection of distinct elements, and there are standard ways of manipulating and combining sets. You can form their union, their intersection, or you can take one set and take the set difference of that set with another. And in SQL, we refer to these as union, intersect, and accept. Because we're in an SQL context, the elements of our sets here are tuples within a relation. So you can consider a relation to be a set, and each tuple in that relation is the element of the set. And because we're in a set semantics, this case, we'd say there are no duplicates in the relation. Or if there are duplicates, we'll ignore them. So let's look at some relations here. And I've written them sort of in an encoding on the left that we can decode on the right. So we have two relations, R and S. R has 8 tuples, 4 copies of tuple A, 2 copies of tuple B, a copy of tuple C, and a copy of tuple D. And on the right-hand side, I'm showing you what the actual tuples are that correspond to those references, those encodings. So really, this is a table of 8 tuples with 4 copies of this A tuple about Jim, 2 copies of the B tuple about Marcella, 1 copy of the C tuple about Gail, and 1 copy of the D tuple about Godard. Okay? And now S has got 2 A's, 3 B's, a C, and an E. When we use the set semantics, we take the union of R and S. The union is going to have set as output, which means it's really only going to have 1 copy of each value in the output. So A is in both R and S, so it'll be in the output. B is in both R and S, it'll be in the output. C is in both R and S, it'll be in the output. D is in R, so for the union, it'll be in the output. And E is in S, so it'll be in the output. But only 1 copy of each because it's set semantics, so we ignore the duplicates. Intersect keeps only those tuples that are in both R and S, which is A, B, and C, and we get 1 copy of each in the output. And accept is going to be those tuples in R except for tuples that appear in S, which leaves us with just tuple D. Notice that in the default set semantics, all these operators have no duplicates in the output because they're set semantics. Now let's shift from sets to multisets. And the keyword all in SQL is going to be our cue that we're working with multiset semantics. In multiset semantics, we're going to keep track of the number of copies or the cardinality of each tuple. So in the relation R, we have 4 A's. And we might, as a shorthand notation, write it down as we do here as A with a 4 after it. We have 2 B's, 1 C, and 1 D, and so on. This notation is going to be handy for explaining things here. You don't actually use this notation in practice. We're just going to use it for explanatory purposes. So we've got our cardinalities of each tuple written down next to them, all right, in this all multiset semantics. And then SQL has these all variants of the set operators. So union all is going to form the union of 2 multisets. And the cardinalities of the tuples in the output are going to be the sums of the cardinalities of the tuple in the input. It's as if we're keeping 1 copy in the output for each copy in the input. So for A, there were 4 A's in R, there were 2 A's in S, so there are going to be 6 A's in the output of union all. For B, there were 2 in R, 3 in S, so there's going to be 5 B's in the output. For C, there was 1 in each, so there's going to be 2 C's in the output. And there's 1 each of D and E in the input, so there'll be 1 each of D and E in the output. And you can convince yourself here that what we're doing is we're summing up the cardinalities per tuple of the 2 inputs. So that's union all. Intersect all is going to be the minimum of the cardinalities. So looking at the A's, there's 2 A's in S and 4 in R. So the minimum of 2 and 4 is 2, so there'll be 2 A's in the output. There'll be 2 B's in the output because that's the minimum of B's, the number of B's in R and the number of B's in S. There'll be 1 C in the output because there's 1 C in each, and no D or E for the intersect. Okay, so the semantics here is the minimum of the cardinalities of the matches. And then accept, as you might have guessed, is going to be the difference of the cardinalities. We've got 4 A's in R, 2 A's in S. So R, except all S, is going to have 2 A's in the output. R, except all S for B's, is going to be 2 minus 3, which is below 0. So there's actually no B's in the output of this query. There's also no C's in the output of this query because there's an equal number of C's in R and S. All right. There is a D in the output because there's 1 D in R and no D's in S. And of course, there's no E in the output. Okay. So the semantics for accept all is to take the difference of the cardinality.